Are you preparing for a cybersecurity interview and want to ace it? Here are some common questions asked during interviews. Let's start with understanding the difference between HTTP and HTTPS, and how each protocol works. HTTP, or Hypertext Transfer Protocol, is the foundation of data communication on the World Wide Web. It operates on port 80 and is unsecured, meaning data is not encrypted and can be intercepted. On the other hand, HTTPS, which stands for Hypertext Transfer Protocol Secure, operates on port 443 and is secured by Transport Layer Security, TLS, or Secure Sockets Layer, SSL protocols. These protocols encrypt the data transferred between the user and the server, providing a layer of security that safeguards against eavesdropping and tampering. So, when you're surfing the web, a website with HTTPS in its URL is ensuring your data is securely transmitted. So, that's the basic difference between HTTP and HTTPS. Keep this in mind as you prepare for your interview. The next topic to conquer is DAST and SAST. Do you know what those acronyms stand for? Let's dive in. DAST, or Dynamic Application Security Testing, is a process that deals with finding security vulnerabilities while an application is running. It's like a real-time security guard, always on the lookout for potential threats. On the other hand, we have SAST, standing for Static Application Security Testing. Unlike DAST, SAST scans an application's source code to identify security vulnerabilities. You can think of it as a preemptive strike, identifying potential issues even before the application is up and running. While both serve the same ultimate goal of ensuring application security, they approach it from different angles. SAST is like a building inspector, checking the plans for potential issues. DAST, in contrast, is more like a fire marshal, actively looking for problems while the building is occupied. That wraps up DAST and SAST. Remember these definitions as they are common in cybersecurity. Have you heard of the term zero trust? Let's delve into what it means. At its core, zero trust is a cybersecurity philosophy that operates on the principle of never trust, always verify. It's a strategy that eliminates the concept of trust from an organization's network architecture. One might ask, does this mean we can't trust anyone or anything? Well, not exactly. It simply means that no user or device, whether inside or outside the network, is automatically trusted. Each request for access undergoes rigorous verification before being granted. This approach ensures that even if a threat actor gains initial access, moving laterally through the network becomes a Herculean task. Zero trust is like having a wary watchdog, always on guard, ready to sniff out anything suspicious. So, remember this when thinking about zero trust. It's not about mistrust, but about rigorous verification. That's zero trust in a nutshell. Always assume breach. SQL injection is a common security vulnerability. Let's understand what it is and how to prevent it. SQL injection is a code injection technique that attackers use to insert malicious SQL statements into an entry field for execution. Think of it as an unwanted guest who sneaks into your house because you left the door unlocked. This can wreak havoc, as it can give an attacker unauthorized access to sensitive data such as customer information, personal details, or proprietary corporate data. Now, how do we prevent this unwanted guest from entering our house? Firstly, we must validate user inputs to ensure only expected inputs are processed. Secondly, parameterized queries can be used to help separate SQL code from data, preventing the execution of harmful inputs. Lastly, regularly updating and patching your database management systems can protect against known vulnerabilities. SQL injection can be dangerous, but with the right precautions, it can be prevented. If you have gotten this far in the video, please like and subscribe. Let's now explore the 7 layers of the OSI model. The Open Systems Interconnection Model, or OSI model, is a conceptual framework used to understand and describe how different network protocols interact and work together to provide network services. Starting from the bottom, the first layer is the physical layer. This layer deals with the electrical and physical specifications of devices and networks, including the layout of pins, voltages, and cable specifications. Think of this as the hardware that physically connects devices in a network. Moving up, we have the data link layer. This layer provides node-to-node data transfer by physically passing data on the local network. It also corrects errors that might have occurred at the physical layer. Ethernet and MAC addresses operate at this level. The third layer is the network layer. This layer handles the routing and forwarding of packets, including the addressing and identification of the route a packet takes to traverse the network. The Internet Protocol, or IP, operates at this layer. Next is the transport layer, the fourth layer. This layer ensures the reliable arrival of messages and provides error-checking mechanisms and data flow controls. Familiar protocols like TCP and UDP operate here. At the fifth layer, we have the session layer. This layer manages sessions between applications, establishing, managing, and terminating connections between local and remote applications. The presentation layer comes in at the sixth position. This layer transforms data to provide a standard interface for the application layer. It handles encryption, compression, and translation of data. Finally, the seventh layer, the application layer, is the closest to the user. This layer provides network services to the applications and ensures that the user's software can access network services. Protocols like HTTP, FTP, and SMTP operate at this level. That's the OSI model for you. Remember, each layer plays a crucial role in network communication. Understanding this model is key to grasping how different network protocols interact and work together to provide network services. Next up, we have zero-day exploits and network sniffing. Are you familiar with these terms? Let's dive in. A zero-day exploit refers to a software security flaw that's unknown to those who should be interested in its mitigation, such as software vendors. The term zero-day denotes that the developers have had 0 days to fix the vulnerability. Attackers use these exploits before the developers have an opportunity to create a patch. On the other hand, network sniffing is a method used to monitor and analyze network traffic. It's like eavesdropping on a conversation, but in this case, the conversation is between computers. Network sniffers can be used both for legitimate network management functions and for malicious activities. In the world of cybersecurity, these two concepts play a significant role. Zero-day exploits remind us that even if the software is up to date, there may be vulnerabilities that no one is aware of, including the software manufacturer. Network sniffing highlights the importance of encrypting our data to prevent data and passwords from being stolen. Zero-day exploits and network sniffing are critical concepts in cybersecurity. Keep these in mind. Let's move on to social engineering and rainbow tables. Do you know what they are? Social engineering is essentially a con game that manipulates individuals into revealing confidential or personal information that may be used for fraudulent purposes. It's not about exploiting software or hardware vulnerabilities, but about playing on human vulnerabilities. A common example would be a phishing scam where the attacker pretends to be a trusted entity to trick the victim into sharing sensitive data. On the flip side, rainbow tables are a time-memory trade-off technique used in cracking encrypted passwords. They're essentially pre-computed tables for reversing cryptographic hash functions. Imagine having a massive cheat sheet that helps you decode scrambled passwords. That's what rainbow tables are, albeit a simplified explanation. These two concepts might seem unrelated, but they both highlight the importance of robust cybersecurity practices. Social engineering underscores the need for awareness and education, while rainbow tables emphasize the necessity of strong, unique passwords. Social engineering and rainbow tables are intriguing topics. Click on the screen for more information about rainbow tables. What's your favorite interview question? Please comment below. Finally, let's delve into the concept of a man-in-the-middle attack. In the world of cybersecurity, a man-in-the-middle attack, or MITM, is a tactful and dangerous strategy where a hacker intercepts communication between two parties without their knowledge. The attacker positions themselves in the middle, hence the name, and gains the ability to eavesdrop, manipulate, and control the conversation. Imagine a situation where you are at a coffee shop, using the public Wi-Fi to access your bank account. Without your awareness, a hacker has set up a fake Wi-Fi network that mimics the legitimate one. You connect to this rogue network, and voila, the hacker is now the man in the middle, intercepting all your data traffic. This could include sensitive information such as login credentials, credit card numbers, and personal messages. MITM attacks can occur in various forms. One common type is IP spoofing, where the attacker falsifies network packets to appear as if they are from a trusted source. Another is DNS spoofing, where the hacker alters the DNS server to redirect a domain name to a different IP address. So how do we protect ourselves from MITM attacks? Firstly, keep your devices updated. Software updates often include patches for security vulnerabilities that could be exploited by attackers. Secondly, encrypt your data. Use secure networks and websites that implement HTTPS, which encrypts your data in transit. Another effective defense is using virtual private networks, or VPNs. A VPN creates a secure tunnel for your data to travel through, shielding it from potential eavesdroppers. And remember, avoid using public Wi-Fi for sensitive transactions whenever possible. Lastly, be wary of phishing attempts. Phishing is a common method used by attackers to lure victims into revealing sensitive information. Always double-check the source of the emails and messages you receive. And that's a wrap on man-in-the-middle attacks. Always remember, security is a constant battle.